Hi guys, today we're going to talk about graphing exponential functions. So basically what we're asked to do here, if we look at these tables, we're asked to graph y equals 2 to the x and y equals 2 to the negative x. So let's first graph y equals 2 to the x. Before we graph it, you can see our table of values here. So all we're doing here is taking these x values, plugging them into 2 to the x, so we can figure out our corresponding y value. Okay, so if x is -3, I plug -3 in for x. It tells me then if I plug it in, it's 2 to the -3. And just remember, when you have a negative exponent, we want to change that to a positive exponent so we can evaluate it. How do we do that? We flip the base, so 2 becomes 1 over 2, and then the exponent can change from negative to positive, so it becomes 1 over 2 to the positive 3, which is 1 over 8. Okay, same thing with -2, 2 to the -2, flip the base, and the exponent becomes positive. 1 over 2 squared is 1 over 4. -1, flip the base, becomes 1 over 2 to the positive 1, which is 1 over 2. And then 2 to the 0 is 1. Then I take 1, 2, and 3, plug each of those in, and I get my corresponding y value. So 2 to the 1 is 2. 2 squared is 4, 2 cubed is 8. Okay. The reason I have this other website open here is I wanted to show you guys, and some of you may be familiar with this. This website is called desmos.com. Let me see if I can move this up here just so you can see the website address. So if you just go to desmos.com and you click on Start Graphing, it'll take you to this screen here. Okay, so let's move back down. And again, this is nice and handy for graphing. It can be any graph that you want to draw or see what it looks like. You simply just put in the equation of the graph here, and it'll draw the graph for you. So we want to draw y equals 2 to the x, or see what it looks like. So here's y. I type in y equals 2. And to get my exponent, I hit Shift 6 on my keyboard. Okay, Shift 6 gets me so I can type in exponents, and you can see my cursor there, and I want to type in x. So y equals 2 to the x, and here's what it looks like. The other thing I can do with my Desmos graph is I can play around with the parameters on the x-axis and the y-axis. So if I go to this, what looks like a wrench basically, I can change my graph settings. So I can see here all my y values are positive, so I don't need to go all the way down to -10, for example, on my x-axis. On my y-axis. I don't need to go so far into my negatives. -6 is showing up to now. So let's say I just want to see mainly positive numbers. Let's say I'll go from -1. So you can see now the graph shifts, and it shows me anything above -1. And I know it goes higher than 6. Definitely goes higher. I can't put an infinite, I guess, number on my y-axis. But let's say I want to see a little bit higher, so I'll do up to 25, for example. So there's 25. Let's say, oh, you know what, that's too high. Let's just go up to 20. And there's 20. The other nice thing is now you can see the x-axis is labeled at every 5, so it goes 5, 10, 15, 20. If you want to change that, you can go to Step here. You could label it every 4, for example. You could label it every, not 42, but every 2, for example. You could label it every 1, for example. So you can basically change the parameters however you wish to see, whatever you want to see on your y-axis and also on your x-axis. So let's say I don't want to go so low on my x-axis. Instead of -10, I just want to see till -4. And on the positive x, let's say I only want to see till +4. So you can play around with that. So there we see our graph, y equals 2 to the x. And if we look at our table of values, right, you'll see that -3 and 1/8, -3 and 1/8 is there, -2 and a quarter is there, -1 and a half is there, 0 and 1 is there. So all the coordinates we have here are matched there. Okay. The other part that we're asked here is to draw y equals 2 to the -x. Okay, so same thing. Take your x values, plug them in to the equation, and get your y value. So just be careful here. It's 2 to the -x. So if I plug in a negative number, like I do here, so 2 to the -x, if I plug in -3, it becomes -3, which gives me 2 negatives, gives me a positive. So 2 to the 3 is going to be 8. If I plug in negative 2, it's 2 to the negative 2, which becomes 2 to the positive 2. This should say 2 to the 2 here, which is 4. And then 2 to the negative 1 becomes 2 to the negative 1. Double negative again gives me a positive. So 2 to the 1 gives me 2. And then as I keep doing the same thing over here, when I plug in a positive x value, it becomes a negative exponent because it's 2 to the negative x. Okay, so you can basically see here, these values, the y values, are a reverse of what they were here. Here we went from 1/8, 1/4 up to 8. Now we go from 8, 4 down to 1/4, 1/8. Okay, what will that graph look like? Well, it'll be a mirror image of y equals 2 to the x. So let's see here, if I do y equals 2, and again shift 6 to the negative x, and you can see the graph of y equals 2 to the negative x in blue. So it is a mirror image of the graph of y equals 2 to the x, right? So it's basically reflected in the y-axis. Okay, so that's what our graphs look like for y equals 2 to the x and y equals 2 to the negative x. And if I go back to my lesson sheet here, they're drawn for us in here. So the reason this was in orange here is that you see the graph of y equals 2 to the x in orange. And the reason you see these green squiggly lines here is that you see the graph of y equals 2 to the negative x in green. Okay. To tell whether a graph is increasing or decreasing, we look at it moving from left to right on the x-axis. So start on the left, go to the right. If your y values are going up, like it is on the orange graph, right, then we say the graph is increasing. If when we move from left to right, our y values are going down, like you see on the green graph, then we say it's decreasing. Okay, so if you're ever asked whether it's increasing or decreasing, go from left to right and just check to see if the y values are going up, it's increasing. If the y values are going down, it's decreasing. Okay. Another, I guess, piece of information or a definition is this word here, asymptote. And I don't know if any of you guys have heard this word before. I'm assuming no, but either way, the definition of an asymptote in terms of when we are graphing is a line a function approaches but does not touch. So it's basically a line that your graph gets closer and closer to but never touches. In this case, if we look at our graph of y equals 2 to the negative x in green, you'll notice here it keeps going down and it gets closer and closer to the x-axis but never actually touches it. And then the same thing with the orange graph of y equals 2 to the x. If we go into the negative x values, this graph will get closer and closer and closer to the x-axis but never touch it. So because it gets closer and closer to the x-axis but never touches it, then that is called an asymptote. So the asymptote in this case would be the x-axis, which is also equivalent to y equals 0, right? Because y equals 0 is a horizontal line at the x-axis. Okay, so moving on to our table here, if we look at the graph of y equals 2 to the x, is it increasing or decreasing? Well, we already looked at increasing and decreasing. So y equals 2 to the x is in orange. It is increasing. Okay. What's the y-intercept? Well, where does it cross the y-axis? It crosses it at a value of 1. So you can say 1 at y equals 1, or the coordinate is actually 0, 1. The asymptote we talked about is the x-axis, or y equals 0. The domain, what values can x be? Well, if we again look at y equals 2 to the x in orange, x can be any negative value. I can plug in any negative number into this x value and I'll get a y value. I can plug in negative 1,000,000, right? 2 to the negative 1,000,000 will give me 1 over some crazy big number, but it'll still be some value. So it can be any negative x value and it can be any positive x value. I can plug in 1,000,000,000 or 1,000,000,000,000 in for x and I'll still get a y value. So that's why x is all real numbers. The range we can see is our y values, and just remember that this is our y value. So on the y-axis, you can see the y values never go into the negatives, and remember, they never touch 0. So the range then is y is an element of all real numbers such that y is greater than 0, but not equal to, right? It never equals 0. So that's why we make sure we write greater than, and we don't put that line underneath to represent equals to. Okay. Can you write the equation of an exponential function that is increasing more quickly than 2 to the x? Basically, as long as this number here, the base of our power, is bigger than 2, it'll increase faster than 2. So 3 to the x works, 4 to the x, 7 to the x, 10 to the x, 100 to the x, any number bigger than 2. Okay. Can you write the equation of an exponential function that is decreasing? Add it to your graph above. Well, we've already done that, right? We graphed y equals 2 to the negative x, and we saw that in green here is decreasing. Okay, so 2 to the negative x, again, is the same as, if we flip the base, 1 over 2 to the positive x. Okay, so both of these are the same, and they're both decreasing. Which of the following exponential functions are increasing and are decreasing? So basically, if the base of our power is bigger than 1, it will be increasing. If it's between 0 and 1, it will be decreasing. Okay, so 3 is bigger than 1, increasing. A half is between 0 and 1, decreasing. 4 to the negative x, be careful here because the base is 4, but if we write this as a positive exponent, the 4 needs to be flipped to 1 over 4. Now it's between 0 and 1, our base, so it's decreasing. 0.25 is between 0 and 1, so it's decreasing. 3 to the negative x, again, it's negative x. We have to flip the base. It becomes 1 over 3, so it's decreasing. And the base here is 2, which is still larger than 1. We don't care about the 5 here in this case. As long as this number is larger than 1, the base, then it is increasing. Okay. And the last bit here, number 5, use the constant ratio and the y-intercept to plot the function y equals 4 times 2 to the x. So what they mean by constant ratio is the base. So the base is 2, and the y-intercept is this value here in front of the 2. So that'll always hold true. So this value here is 4. That'll be your y-intercept. The ratio is 2. So how are we going to graph this? Basically, let me go back up here. Y-intercept of 4. So I know I'm at a y-intercept of 4. The ratio is 2. So every 1 I move over on the x, I have to multiply my y by 2. So y is 4 here when x is 0. If I go up to 1, then 4 times 2 is 8. If I go up to 2, I multiply 8 by 2, it'll be 16. Okay. If I go down on my x-axis, so if I go down to negative 1, I need to divide my y value of 4 by 2. So if I go to negative 1, 4 divided by 2 is 2. If I go down another 1, I need to divide 2 by 2. That means negative 2 and 1 is my coordinate. Then I divide 1 by 2. If I go over here, becomes a half. Okay. So you'd keep dividing by 2 to get those values. If I go to the right, I keep multiplying by 2. Okay. If this ratio was 3, I'd keep multiplying by 3. And then I'd keep dividing by 3 as I go down by 1. Okay, so that's how you would graph using the constant ratio and the y-intercept. If you're given a table of values and you're asked to come up with the equation for the graph, right? This value here will always be your y-intercept. So wherever x is 0, there's your y-intercept of 4. The ratio, take any y value and divide it by the y value before it. So take my second y value, divide it by the first. 20 divided by 4 is 5. Or I could take my third y value, divide it by the second. 100 divided by 20 is 5. 500 divided by 100 is 5. So that's where we get our ratio of 5. So your equation is simply 4 times 5 to the power of x. Okay, so the practice sheet is, if you look at the blank file, it'll be in there for practice questions. And if you have any questions, as always, feel free to contact me. Okay, thanks, guys.